First, I thank the Pontifical Academy of Sciences most sincerely for admitting me as a member. I really deeply appreciate the honor, and I also embrace the responsibilities which most certainly go along with membership of this body. I was born in Port Elizabeth, South Africa. Port Elizabeth has a new name now. It's called Gqeberha. I'm of Indian heritage, part of the third generation of my family, born in South Africa. So I'm an accidental mathematician in the following sense. My formal education was in engineering, civil engineering to be precise, at the University of Cape Town, and a PhD at Cambridge University, and even a postdoctoral period in engineering at University College London. But the thing is, my work at the time, and still now, lies at those fertile interfaces between engineering, material science, and mathematics, mathematical aspects of mechanics. And it is this positioning or location that inspired me to bridge mathematical and engineering perspectives in my work, and which has determined the shape and the trajectory of my career as an applied mathematician at the University of Cape Town. So I work on problems in the mechanics of continuous media, solid mechanics, fluid dynamics, in which the general program, as I see it, comprises mathematical modeling of material behavior, analysis of those models, which typically take the form of partial differential equations or variational problems, and then also construction and implementation of algorithms to obtain computational solutions. A major area of application has been in the domain of plasticity. So these are materials like metals that undergo irreversible deformation. And I've pursued problems in this area for some decades, following the program of research that I referred to earlier. If I were to mention any aspect of it, of which I'm particularly proud, it would be the work that I've done on variational problems, particularly variational inequalities, and also the numerical analyses that have gone along with that work. In keeping with my dual, or shall we say complementary allegiances, the mathematical approach to my work has most of the time being informed by experimental work in material science, while the mathematical results and the predictions have, I think, provided novel insights into the phenomena for my colleagues in material science and engineering. I should also like to mention another area of activity, being investigations in biomedical mechanics. This would include work in cardiovascular mechanics, the design of stents, prosthetic vein grafts, aortic valve leaflets, and the like. Much of this work I've carried out in collaboration with colleagues at the medical school in Cape Town and elsewhere. For the last almost 15 years, I've become increasingly involved in activities at the interfaces between science and policy and society. In particular, working to ensure that science is integrated into policy development, that relevant policies support and promote the pursuit of scientific knowledge and the needs of science, and working also to protect scientific freedom and advocate principles for the responsible practice of science. I've pursued these activities through our academy, the Academy of Science of South Africa, through networks of academies such as the Inter-Academy Partnership, and also the International Science Council, which I was privileged to serve as its inaugural president. So now I'm a professor emeritus and retired, but as we all know, this is not at all an accurate description of this stage of my life. Thank you.